2 hydrocarbons. Part 2 I will explain. So in this, what is that? First one is Corey-House synthesis. What is that here? Corey-House synthesis. It is that very good reaction. That means in this by using this one, we can prepare even number and odd number of alkanes also. We can prepare even number and odd number of alkanes also. See once down. Here it's given. See one, this method is the best method. Then Wood's reaction can be prepared symmetrical as well as unsymmetrical alkanes. Having odd number and even number of alkanes also we can prepare by using Corey-House synthesis. Corey-House synthesis. Okay, students. So this is a point. So in this, if you take it the alkyl halide, so alkyl halide when it is reactive with lithium, okay, alkyl lithium organometallic compound form. How this reaction is taking place mean through the formation of organometallic form compound. So here first organometallic compounds will form. Organometallic compound. Hmm. So this is first point organometallic compound. In the second, nucleophilic substitution takes place. Yeah, nucleophilic substitution taking place. Nucleophilic substitution takes place. In that end, carbon-carbon bond is formed. Carbon-carbon bond is formed. Okay, students. So these are mainly taking place here. Now I am explaining. So this alkyl halide, when it is react with lithium in the presence of ether, their alkyl lithium is forming. That alkyl lithium, when it is react with copper halide, dialkyl lithium cuprate is forming. Dialkyl lithium cuprate. This is the main reagent. This one is main reagent. It is only organometallic compound. So this one, when it is react with the alkyl halide, when it is reacting with alkyl halide, then what is happening? So this halide means generally having negative charge. This negative charged halide is replaced by okay negative charged alkyl group. Why means any alkyl halide, any alkyl group, when it is combining with metal, it gets that alkyl group gets negative charge, metal gets positive charge. So this R minus is combining with here this is R plus. So what's happening there? This X minus is replaced by R minus. So that's why we'll call this is nucleophilic substitution reaction. Here organometallic compound is forming. So that's why organometallic compound. Here nucleophilic substitution. Why means this alkyl halide is replaced by R minus. And end which bond is forming? Alkane is forming R bond R dash. That means carbon carbon bond is forming. So that's why carbon carbon bond is formed. Okay, students, it is Corey-House synthesis. By using this, we can prepare. Okay, what is that? With good yield, we can prepare even number and odd number of alkanes. We can. Okay, students, what the reaction here? This one, Corey-House synthesis. What is it? Corey-House synthesis. Okay, so next Franklin reaction. Franklin reaction means it is also through organometallic compound. So that reagent is called Franklin reagent, dialkyl zinc values. Here what is happening? Alkyl halide when it is reacting with zinc, there what is forming here? So there alkane is forming. Alkane is forming. Higher alkanes are forming. Alkyl halide when it is reactive with zinc dust, higher alkanes are forming. Higher alkanes are forming. Okay, so in this case what is happening here? See one students, in this here if you take in, so first here homolytic cleavage taking place. Here radical, here also homolytic cleavage. So Br radical is there. To that Br radical, zinc metal, one zinc metal, two Br radical. Ah, So zinc having outermost 2 electrons. Okay, 4s2. So it's giving those 2 electrons to these two Br radicals. There we are getting Zn plus 2 and 2 Br minus. Zn plus 2, 2 Br minus. That way, what you are getting there, zinc bromide, Zn, Br2, we got it. Okay, students, zinc bromide, you got it. So, zinc bromide. And one more zinc. So, like that, here, what is there? Two CH3 radicals are there, two methyl radicals. So these two methyl radicals combining with zinc. I mean zinc has outermost 2 electrons. These two methyl radicals forming organometallic compound, that is dialkyl zinc. What is it here? Dialkyl zinc. What is the name of this one? Organometallic compound. It is, what is it? Organometallic compound. Organometallic compound is forming. This organometallic compound, by using this, when it is reacting with the alkyl halide, this organometallic compound, when it is reacting with alkyl halide, what is happening here? Nucleophilic substitution. Same like Corey-House synthesis. Nucleophilic substitution. Here also organometallic compound is forming, nucleophilic substitution is happening, and carbon-carbon bond is forming. So here what is that? Here Br minus is replaced by CH3 minus. So there alkane we are getting CH3 bond CH3. This way ethane we are getting. Ethane and methyl zinc bromide. It is also taking place through what is that organometallic compound? That organometallic compound reagent is called Franklin's reagent. Okay, students, understand? So next, Grignard's reagent. When you take Grignard reagent, it's very famous reaction here. Many NEET exams have seen like this equation. Grignard reagent. In that Grignard reagent, when you take it, in this Grignard reagent, alkyl halide in ether, when it is reacting with magnesium. So there what you can get it, Grignard RMGX. Grignard reagent means what is that? RMGX, alkyl magnesium chloride. Okay, alkyl magnesium halides are called Grignard reagents. Alkyl magnesium halides are called Grignard reagent. That Grignard reagent, it's having more affinity towards proton. More affinity towards proton. So in this case here H plus ion is there. Here Grignard reagent, in that magnesium gets positive charge, alkyl halide get negative charge. So here this is getting positive charge, this is getting negative charge. So what will happen then? R minus, this R minus and H plus combined together, there we are getting, so what is that? Alkane we are getting. What we are getting? Alkanes. Like that, any substance if it is having, any substance if it is having polar hydrogen, proton, H plus ion, that case we can prepare from Grignard reagent alkanes. Okay, I will show you now. See, CH3 minus Mg plus and H plus OH minus. Now this CH3 minus this H plus combined together and giving methane. Methane plus MgBr OH, we got it. Next, Grignard reagent, here Mg plus and CH3 minus. In this case, here RO minus H plus, RO minus H plus. This CH3 minus, this H plus combining together gave alkane. Methane gave plus MgBr, MgBr OR, we got it, alkoxide. So next case if you see here CH3 Mg plus CH3 minus, Mg plus CH3 minus, here Mg plus CH3 minus, here COO minus, CH3CO minus, H plus if you take it, there also you will get it CH4 plus plus one other compound is what is that? Magnesium bromide acetate ion will get it CH3COO minus. So like that from Grignard reagent we can prepare alkanes. When that given Grignard reagent is reacting with the substance which is having polar hydrogen, which one able to donate proton? Okay, so this. Next, red phosphorus red phosphorus here this is very strong reducing agent. Red phosphorus is very strong reducing agent. That's why what's happening? So in the presence of the strong reducing agent, any group, most of the groups means, see, it is powerful reducing agent, so it can convert. Okay, it can convert aldehydes, ketones, alcohols, carboxylic acids to alkanes with the same number of carbon atoms. That means without changing carbon atoms, it can convert aldehydes, ketones, alcohols, carboxylic acids to alkane with same number of carbon. So first, if you take it alcohol, first one is what is it? This is alcohol. This alcohol, when it is reactive red phosphorus what we are getting then? There we are getting, okay, alkane we got in. Next, aldehyde. That aldehyde group also, when it is reactive with this one, there also will get it alkanes. Like that, this case, this side what you are preparing? Alkanes you are preparing. Alkanes we got in. Understand, students? So like that, all aldehydes, ketones, carboxylic acid all converted into the respective alkanes without changing carbon atoms. So that means reactant what it's having number of carbon atoms, products also having same number of carbon atoms. Products also having same number of carbon. This is by using red phosphorus strong reducing agent. Strong reducing agent. Okay, now some solved examples we'll discuss. So it is related to Grignard reagent give alkane. Grignard reagent is giving alkane here. Huh. So Grignard reagent gives alkanes means very simple. RMGX already we discussed here. RMGX Grignard reagent means what is it here? RMGX. Here I alcohol. A option what is that? Alcohol is given. It's having H plus O minus. So this H plus and R minus both can combine and gives alkane. So first one is right answer. And second, if you take in your nitrogen is combined with hydrogen, that means your electronegative difference is there. That H plus also polar hydrogen. So this polar, now nitrogen when it is going to H plus, this is polar hydrogen, here R minus. These two combined together gives alkanes. And next water. Water also here HOH. Here OH minus H plus. This proton, this H plus proton and R minus both combined together and giving alkenes. Giving alkenes. So answer what is that? Answer will be A, B, C. All are okay. All A, B, C are answers. A, B, C are answers. Okay, students. Next, Kolb's synthesis. Kolbe synthesis. We did not discuss this one preparations of alkanes here. Here I will explain. Kolbe synthesis when you take in Kolbe synthesis of alkanes using sodium salt of butanoic acid. So now I will explain here this one. I'm going to explain to you Kolbe synthesis by taking one example to you. One example I'm taking and I will explain to you. See once here Kolb's electrolysis. Kolb's electrolysis. Here, what I am taking here, electrolysis means anode and cathode we require. So here I am taking sodium acetate. I am taking this sodium acetate. Whenever we are adding to water, what will get it here? Acetate ion CH3CO minus and Na plus we are getting. So HCO minus and Na plus. And water is there. Water also will undergo okay dissociation. It gives H plus and OH minus. H plus and OH minus. Okay, students. So now here that solution contain okay two anions, two cations. What are those anions? Acetate ion, hydroxide anion. Cations Na plus ion, H plus ion. Okay. So now at anode, what is happening? At anode, this is only very important here. At anode, which reaction takes place? Oxidation. Electrode at which oxidation takes place. That electrode is called, what is it called here? That electrode is called anode. So now CH3CO minus OH minus, according to electrochemistry, which one move towards anode means a state ion. CH3 huh? COO minus. Now two acetate ions take it here. So these two acetate ions when those are moving towards anode, at anode oxidation should take place. So this acetate ion losing electron and it is giving like this. One electron is giving to one, each acetate ion giving one electrons to anode, and there we are getting two electrons. How it is happening means I am showing to you. See, double bond O. Oxygen valency, what is that here? Oxygen not valence, 6th group element. So it's forming one bond. Remaining, how many electrons will be there? So remaining, hmm, like that 5 electrons. Now if you put one more extra electron, it got negative charge. It's got negative charge. So this is state ion here like this will be there. Now when it lost electron at anode, there which one we will get it? This one will get it. CH3 bond C double bond O. Whatever extra electron it has, that one lost by this like this. So that's why radical you got in. Okay. So this one unpaired electron, here also unpaired electron. The next step, what is happening? Next step, here CH3, C double bond O, okay, this one here radical is there. Unpaired electron, unpaired electron. Now these I am taking two. So these two if I take in, here homolytic cleavage. Here homolytic cleavage takes place. When homolytic cleavage is taking place, here one unpaired electron, here one unpaired electron will get it. Homolytic cleavage is taking place. Homolytic cleavage takes place. So what you will get then? So when homolytic cleavage is taking place, two CH3 radicals. There you will get it, two CH3 radicals plus, okay, this radical and this radical both combine together, one new bond is forming. So like that, that new compound is what is that here? C double bond O, double bond O. Already between carbon carbon one bond is there. So this radical combine one more bond is forming. Like that carbon dioxide you got it. What you got it? Here you got it carbon dioxide. Okay, so here I have taken two molecules. That's why two carbon dioxide molecules I got it. What I got it? Two carbon dioxide molecules, two CH radicals. Now those two CH3 radicals, those two CH radicals combine together and giving ethane CH3 bond CH3. Like that, what I got? 1 mole of ethane I got it here. Here I got it 1 mole of ethane. In this case, here I got it 2 mole of carbon dioxide. So at the anode, okay, when acetate ion moving towards anode, what I got? 2 moles of carbon dioxide, 1 mole of ethane liberated at anode. Liberated at anode. Next, at cathode. At at cathode, if I take at cathode, what is there here? At cathode, hmm. So Na plus and H plus, which one move towards anode? At cathode, which reaction takes place? reduction takes place. So if I take it H plus and Na plus, according to electrochemistry, H plus easily undergo reduction than Na plus. So two H plus ions move towards the cathode and takes two electron undergoing reduction and giving hydrogen gas. So it produces 1 mole of hydrogen gas. 1 mole of hydrogen gas. Remaining ions in solution. In solution, what will be there here? In solution, what will be there? Na plus ions. Okay, OH minus ions will be there. Those two combine together, and there you will get it NaOH solution. So that means, so during electrolysis of during electrolysis of sodium acetate, during electrolysis of sodium acetate acetate at anode carbon dioxide and alkane will be produced will be produced and at cathode hydrogen gas will be liberated. Hydrogen gas will be liberated and and solution will become basic, and solution will become basic. Okay, students, understand? So this is what is a Kolb's electrolysis here. This one is Kolb's electrolysis. Okay, so this one. Now here Kolb's electrolysis related some questions are there. Those we'll discuss. In that Kolb's electrolysis, what is given? Butanoic acid and acetic acid. When we take it, ethane we got it. That means there loss of carbon atoms are there. What is there? So here I have taken acetic acid. So what I have taken then, okay, acetate ion, this acetate ion I have taken, we are losing one carbon. So carbons combine together, ethane we are getting. Ethane we are getting. Okay, students. So now, here Kolb's electrolysis of alkane using sodium salt of butanoic acid means. So butanoic acid means what is the CH3, CH2, CH2, COOH. This is butanoic acid. But in that basic medium salt they are telling that. So what we have to take it then? So COONA. This one gives. So one carbon should lose. So there you can get it after when we are losing this COONA, remaining three carbons combined with another molecule three carbons. There you can get N-hexane. So like that straight chain C1, C1, C. See how we got this one. So once see that, okay, this one, what is that? Above reaction, Kolb's electrolysis, if you see, you will get full clarity. Like that, answer is N-hexane. Answer is N-hexane. Electrolysis of aqueous solution, sodium butanoate gives main product. Main product sodium, just now we discussed that sodium butanoate gives main product hexane. Main product is hexane. How it is here? It's given here. See once here if you see that sodium butanoate and losing Na plus and here this one you got in. Okay, next COO minus is converted into radical by losing electron. Here two electrons we have to put two electrons. After that, here next what is happening? This COO is going out in the forms of carbon dioxide. Like that, propyl radical you got it. So two propyl radicals coming together and giving one long chain. That is called N-hexane. Okay, students, understand? So like that we got here N-hexane we got it. This one is N-hexane. Okay, students. So this next Corey House reaction involves Corey House synthesis. Already clearly I explained in that organometallic compound will form and nucleophilic substitution will be there and develop that carbon-carbon bond, and it's not a nucleophilic addition reaction. So this is wrong. Remaining all are correct. Remaining all are correct. Corey House synthesis. So a organometallic compound, nucleophilic substitution, development of new carbon-carbon bond. Next, Wurtz reaction. Wurtz reaction, if we take methyl chloride and ethyl chloride, then product will be, whenever we are taking methyl chloride and ethyl chloride, we don't get okay good yield of alkanes. That's why it's not prefer for odd number of alkanes. What you will get? So here already down is given. Check it. See here methyl chloride is given means first two methyl chlorides and to sodiums in the presence of ether. In all cases, we must use ether, dry ether. Dry ether we must use. There, what's happening? These two chlorines, those two chlorines here with the two sodium atoms going out, and here ethane we are getting, and ethyl chloride and methyl chloride. Those two reacting sodium. This way here propane we got it, and ethyl chloride, when those two reacting each other in the presence of sodium, there we got it butane. Like that, here mixed products we are getting. What we got it? Ethane we got it, propane we got it, butane. That's why, okay, here three products we are getting. That's why we are not getting any one product with more yield. Hmm. That's why it's not suitable for preparation of odd number of alkanes. So here, what is that answer? Yes, C option you can take in propane, ethane, butane. And next, butane cannot be obtained by. Oh, in this reaction, if you take it this, butane cannot be obtained by action of soda lime on sodium butanoate. It is very good reaction here. Decarboxylation. It is example for decarboxylation. Decarboxylation in this sodium butanoate. Sodium butanoate means here down explanation is given here. This is sodium butanoate. So this is when it is reactive with NaOH and CaO. Here the mixture of NaOH plus CaO. This is called soda lime. That one is called soda lime. So in the presence of soda lime, which reaction takes place? Decarboxylation. What is happening here? Decarboxylation takes place. When decarboxylation takes place, so it's losing the CO2 and this CO2 and these two sodium atom. That means here like this, it's going out. Na2CO3 is going. This hydrogen is combining with this carbon. Like that, what he got it? Propane he got it. And the specialty of this one, here also one carbon, that means reactant having four carbons means products having three carbons only. Okay, one carbon less will be there. That's why by using this, by using soda lime, we cannot prepare butane. By using sodium butanoate, when it is undergoing decarboxylation, it is giving propane. It won't give butane. So, for A option, we can take it. Next, Clemmensen reduction. Clemmensen means what is given? Butanone is given. Butanone. So, butanone means what is that? This substance. Butanone means this one. When it is undergoing Clemmensen, part 1 we discussed. So butanone, when this butanone, when it is undergoing reduction in the presence of zinc amalgam concentrated HCl, zinc amalgam concentrated HCl, this CO will become CH2. So this way you can get butane. What you can get it? Butane is we are getting. Okay, Clemmensen reduction. Next, action of water on butyl magnesium iodide. So, butyl magnesium iodide means already we discussed this topic and above reactions. Here, what is that? Magnesium will get positive charge and this alkyl group getting negative charge. Water contain proton and hydroxy group. Like that, what's happening? This H plus and this minus combined together, it gives butane. It's giving what is the substance here? It is giving butane. Okay, students. And Sebaster-Sandens reaction. Here, which compound they have taken? Butene. Okay, butene means what is it here? This one. This butene, Sebaster-Sandens reaction means what is the alkenes and alkynes. Alkenes and alkynes converted into alkanes in the presence of nickel, palladium, platinum. It is syn addition. Okay, here syn addition. In the part 1 we discussed clearly about this one. Here which reaction is taking place? Syn addition of hydrogen atoms taking place. So here also we are getting that butane. What you got it? Butane. So except first reaction, remaining all reactions we got it butane. That's why which is not able to give butane means what we have to take it? Action of sodium lime on sodium butanoate. Okay, students, this reaction. Next, next one, which of the following compounds cannot be prepared by Wuj reaction? Which of the following compounds cannot be prepared by Wuj reaction? Which cannot be prepared by Wuj reaction means odd number. Okay, like this compounds. Which cannot be prepared means if you are unsymmetrical alkenes. So unsymmetrical alkene means so we can cut this one into two equal parts. Okay, this one we can cut into two equal parts. But this one and this one we cannot cut into two equal parts. Here, hmm, here A and D are A and D are symmetrical alkanes. A and D are symmetrical alkanes. These symmetrical alkanes we are able to prepare by using Wurtz reaction. But B and C are unsymmetrical alkanes. We cannot cut those into two equal parts. So these are unsymmetrical alkanes. So these unsymmetrical alkane cannot cannot prepare by using Wurtz reaction. By using Wurtz reaction. Okay, it's not favorable to prepare unsymmetrical alkane. So Corey-House synthesis we can use. Corey-House synthesis we can use. So which cannot be prepared by Wurtz reaction means what you have to take it answer B hmm, and C we can take it. Answer is B and C. Okay, students. Next. Next, if you take in here, okay, in this case here clearly is given here. One check it this one. If you have idea, if you see this all, we will get full clarity. Hmm. So methyl chloride and isopropyl chloride, when these two reacting each other, there we are getting like these compounds, mixed alkanes. Mixed alkanes means there we don't get good yield of product. So that one keep it aside. Okay, so this reaction. Next, hydrolysis of ester gives carboxylic acid, which on Kolbes electrolysis yields ethane. The ester is the ester. First, we must write what the structure. First, we must write that a methyl ethanoate. Methyl ethanoate means this is A. This one is A. This ester, this ester when it is under hydrolysis, there we can get acetic acid and methyl alcohol. This acetic acid in the presence of base, there you can get sodium acetate. Already I explained about sodium acetate. This sodium acetate when it is undergoing Kolb's electrolysis, when it is undergoing Kolbes electrolysis, there we can get it. What you can get it here? Ethane and carbon dioxide will get at anode and hydrogen gas will get at cathode and solution will become basic. Hmm. Okay, this one. So answer we can take it A option. Okay, we'll see remaining also. Methyl methanoate. Methyl methanoate meaning B. Methyl methanoate means, yeah, C, this one. In this case, methyl methanoate, when it is under electrolysis, there what you can get formic acid and methyl alcohol will get it. That formic acid, if you take it, this formic acid, when it is reactive with sodium, okay, sodium formate, when it's undergoing Kolb's electrolysis, will get hydrogen gas. What you can get at will get hydrogen gas at anode. At anode and cathode, both cases will get hydrogen gas, not ethane. Hmm. So same way, ethyl methanoate. This is what is it here? It is ethyl methanoate. This one also giving formic acid. Formic acid and ethyl alcohol. Formic acid means formic acid and base. This one you got in. It gives hydrogen gas at anode. And next one, D option is given. What is the methyl propionate? Methyl propionate means this one here. When it is undergoing electrolysis, methyl propionate, when it is undergoing, hydrolysis, when it is undergoing acid hydrolysis, what you got it? Propanoic acid. This propionic acid, when it is react with this propionic acid, when it is react with okay, NaOH, sodium propionate will get it. What you can get it? Sodium CH3, CH2, COONA. Like that you can get in. The sodium propionate, when it is undergoing acid Kolb's electrolysis, there you can get it butane. CH3, CH2, CH2, CH3. Like that, butane we are able to prepare, not ethane. So that's why here which ester are able to give Kolb's electrolysis after undergoing acid hydrolysis. That one is, what is that answer? Methyl ethanoate. Okay, students. So these are the topic. Thank you. Thank you very much.